Okay, in this section we're going to talk about series and sigma notation, and specifically how to use sigma notation to write an expression to represent a series. It gets kind of old to have to write out a bunch of the terms and where the series ends. So some mathematicians came up with a shortcut method for writing a representation of a series. And what they do is they use the sigma notation, which is really a Greek letter from the alphabet, spelling sigma, and it's called the summation sign in mathematics. And it represents, or it is used to represent a series of numbers. And it's a quite useful tool. When we use it, we have to put something here in this area called the summand, but a shortcut thing would be to call it the equation. So you have to look at the series that you're dealing with and think, is there an equation that I can use to represent that pattern? If you look at this, you'll notice that 2, 4, 6, 8, I bet you know the next number, 10. And notice the difference between them is 2, so 2 is added to every term. So what you need to do is come up with the formula for that, and in the arithmetic sequence, if the d is 2 or the adder is 2, do you remember how to write the formula? T1 plus n minus 1 times d. So in this particular sequence, 2 plus n minus 1 times 2, 2 plus 2n minus 2, simplify that, 2n. That's the baby we're looking for. That's the formula. So, to write this series using sigma notation, all I have to do is write the sigma, put the equation right here. Now, I need an index or numbers to put so that I know where to start and where to end. Most often n equals 1 works. If it doesn't, try 0. Sometimes 0 works, or 2 or 3. Now we're going to test. If I put 1 in there for 2n, 2 times 1, I get 2, so I get the first term. So this bottom number gives me the first term. This top number gives me the last term. So I need to figure out what number do I put up here so that I get 100. Is it a 5, 6? It's really not a guessing game. You can take the formula, 2n equal to 100, and solve it. n equals 50. So 50 goes on top. I can check. 2 times 50 gives me 100. This expression is a way to represent that series in a much shorter, concise method. So there's sigma notation for that series. So the trick is you need to write the sigma, you need to find the equation. This is an arithmetic. We also have an equation for geometric. So sometimes you have to use the geometric equation, which is, anyone remember what that one is? T sub 1 times r to the n minus 1 is the geometric. R is the multiplier. And sometimes the series is just a pattern. And you have to look at the pattern and try and figure out how to write an equation for the pattern. Here's an example of a pattern. So I need the sigma notation for that. So I need the equation here, and n equals some number for the start and some number for the end. Now, I don't know if anyone sees the pattern yet, but I see something. So then I think when I'm looking for patterns, how else could I write the number 4? And I think, hey, I could write it as 2 squared. I could write 9 as 3 squared. Ooh, I could write 1 as 1 squared. I want to be able to have the same pattern for all the numbers. 144. 12 squared. All right, so what is the pattern? Some number, whatever it is, squared. So let's write it here, n squared. Now, what number would I put here so I get that first number 1? Do you think it's 1? 1 squared is 1. 1 works. Okay? What number do you think I'm going to put up here to get 144? You think it's a 2? All right. 2 squared? No. What do you think it is? 12. Yeah, I was trying to trick you. So it's 12 squared. So here is sigma notation for that series. So you need the sigma, and then here you need the equation. Sometimes that's a little bit of work. Could be arithmetic, could be geometric, could be neither, which means you have to look for a pattern. Those are hard. And then you need your index for the start, and you need your number for the end. So I think now you can do this assignment. Good luck. All right, I've got one more example of a series here. This one starts with 10, 15, 20, all the way to 100. Do you know what go next? 25, 30, 35, 40. So it seems like we're adding 5, or we have multiples of 5. And sometimes you can just look for a pattern. So this is 2 times 5, 3 times 5, 4 times 5. What's this one? 20 times 5. So if I use the pattern multiplying by 5, all right, so to write sigma notation, put the sigma, I need the formula. So it seems to be different numbers times 5. Numbers times 5. How about 5n? All right. Do I start with n equals 1? Ooh. Hey, that doesn't work. Oh boy, what do I do? Well, think about it. What times 5 is 10? 2. Let's start with n equal 2. Remember I was telling you don't always have to start with 1 there? All right, now I need to figure out the number for the end. Remember how you could solve for it? Take 5n equal to 100. Divide by 5. N equals 20. So I think the top number is 20. Then I double check it. If I put in the first number, 5 times 2 is 10. If I put in 20, 5 times 20, I get 100. How would I get this second term? 5 times 3. Basically, when this is n equals 2 to 20, it means that you try n equals 2, that gives you the first term, 10. When you do n equals 3, you get 15. N equals 4, what do you get? 20. 4 times 5 is 20. So this sigma notation means that you start with, it means that the series they're talking about follows the pattern 5n, and you get the first term by plugging in 2. And to get all the terms, you must plug in all the numbers, starting with 2 all the way to 20. Sometimes you'll have sigma notation and it says write in expanded form. So they want the 10 plus the 15 plus the 20 plus the 25 plus the 30 plus the 35. So if you are told to write it in expanded form, you need to write all of the numbers. Now again, you could shortcut it a little bit and you could go 10 plus 15 plus 20 dot dot dot, and maybe I want to do 95 plus 100, right? All right, good luck.